This is a classic rate problem involving two moving trains. Problems like this are seen in high school texts, in middle school texts, in GRE, GMAT exams. So they are just good old-fashioned fun problems. If you understand them and you can do them, you get a kick out of it. And they're very practical too. So let's go ahead and read the question. The front ends of two trains are 400 miles apart and they're moving towards each other on two parallel and different tracks. The 2-mile long green train is traveling at a constant speed of 55 miles per hour and the 1.5-mile long red train is traveling at a constant speed of 65 miles per hour. After how many hours would the rear ends of the two trains be 600 miles apart? Now, before I solve the problem, I would make sure that when it comes to problem solving, we all understand that we have to understand the question. Half the battle is understanding the question, and then if possible, drawing a nice picture, and then trying to solve the problem. So here's a set of formulas that we're going to be using. We know speed is equal to distance divided by time, and that actually is fairly easy to remember if you understand the unit of speed is miles per hour or kilometers per hour, and that unit comes from this formula. This is the unit. This is a unit for distance. This is a unit for time. So we say the speed is miles per hour. So this one is easy to keep in our mind. This one comes from the second one. You really want to remember the first one. Speed is equal to distance over time. And this one comes from cross multiplication. First, we're going to derive this one informally. If we cross multiply, distance times 1 is distance, must equal speed times time. That's the third formula. And this one, how do you get to the second one from the third one? Which is not terribly difficult. It is divide both sides of this equation by speed, and divide both sides of equation by speed, and you can cancel these two. So time is equal to distance over speed. So if you remember the first formula, it's pretty easy to derive the other two. It's a good idea when you're solving a difficult problem involving speed, distance, and time to write down the formulas. Here's a mnemonic technique. I consider mnemonic techniques pretty cheesy, but we really should understand how formulas work and not just memorize formulas. So I would mention that. However, this is something, the little circle here is something that I have seen some people use to keep these three formulas straight. This is red. Informally, speed is equal to distance over time, time is equal to distance over speed, and distance is equal to speed times time. So if you want to keep it straight this way, that's fine, but you really should understand how these quantities are connected. So that's what you need to know about the three formulas. Moreover, for the problem that we are addressing today, we're going to be only using this formula, only this one. We're going to solve this problem in 3 stages. And you can do it in 1 stage, but I'm going to do it in 3 stages. So initially, if you read the question carefully, the green train is 2 mile long. It's a 2-mile long train, and it's traveling at a constant rate of 55 miles per hour, and the red train is 1.5 miles long and it's traveling at a rate of 65 miles per hour. And the two trains, the front ends, these are the front ends of the two trains, are 400 miles apart. So we're going to pretend that the trains are moving in this way, and this is the scenario that these two trains will achieve. In other words, the trains will travel towards each other till the tips line up. Let me try it again. Till the tips line up like this. My picture is not perfect, but I think you get the point. So we're going to assume to move from here to here, it takes 8 hours. And I'm defining my variable. It's very important to keep your variable straight. So let's define it clearly. Suppose it takes the trains trains A hours to meet, as in scenario 2. Okay, this is my scenario 1 starting point, and this is where they're meeting. And let's say it takes 8 hours. So if both trains are traveling for 8 hours, how far would the green train travel and how far would the red train travel? Well, we can use this formula. This is from the previous slide, the third formula. We know distance is equal to speed times time. So in 8 hours, the green train will travel a distance of 55 miles, and the red train will travel a distance of 65 miles. And these two distances, the distance traveled by the green train and the distance traveled by the red train, should add up to 400. And you really want to get that, because if the trains are 400 miles apart, the tips or the front ends of the trains are 400 miles apart, and if the two trains travel, they're going to together cover a distance of 400 miles. And now we can, this is an important step. You want to pause the video and genuinely understand what's going on. So not a bad thing to do. So when you add 55 to 65, you're going to get 120A must equal 400, and A must equal 400 divided by 120, and that turns out to be 3.33 hours. And this is something we have to keep straight. So 400 divided by 120 is 3.33 hours. So it will take the green train and the red train from the original starting position to come to this scenario 3 1/3 of an hour. This is the next step. And what's going on here is right now the two trains are in a position so that their tips are, the front ends are lined up just like this. Now we want to go from this step to this step where the rear ends are lined up. The green train is moving this way, the red train is moving this way. We want to know how long it would take the green train and the red train to line up in a manner so that their rear ends are essentially touching each other. And we start from here, and we're going to assume, we're going to define our variable. We're going to assume that it takes B hours to achieve this. And what do I mean by this? That simply means, I mean to go from here to here, it takes the trains B hours. B is my variable. Now, when the green train moves from here to here, and the red train moves from here to here, they together travel a distance of the length of the red train plus the length of the green train, which is 3.35 miles. And what do I mean by that? Let me erase this. Now, you have to understand B is our variable. I'll have to erase it too. So keep that straight. I'm going to write down B hours later, but I need the picture to explain something. Okay, what we are trying to say here is this distance is 3.5 miles. 3.5 miles. Where is 3.5 miles coming from? 2 miles and 1.5 miles. The length of the red train is 1.5 miles. The length of the green train is 2 miles. If you add them up, that's 3.5 miles. So when the trains from scenario 1 to scenario 2, when they move from here to here, together they have traveled a distance of 3.5 miles. And we just said it took the two trains B hours. That's important. Again, this is not a bad time to pause the video and really understand where this number is coming from and how we are defining the variable B. If that's the case, we can say that in B hours, the green train travels 55 B miles, and the red train travels 65 B miles, and together they travel 3.5 miles. As before, 55 plus 65 is still 120, and I have 3.5 there. B is 3.5 divided by 120. I will use my calculator, and if you can do it in your head, good for you. I can't. I am getting 0.029166. 29166 hours. So essentially what we found is it'll take the two trains to reach scenario 2 from scenario 1. This is scenario 1 from here to here. It'll take the train 0.029 hours, and we had our answer to the previous part was 3.33 hours. So we'll keep on going. We have one more state scenario to analyze, and then we'll be finished. So this is scenario 2 from here to here, or part 2. It takes the train 0.029166 hours. So this is my last case. What do I have here? This is where I start. The two rear ends are lined up like the previous case. And now we want to find out, let me draw the straight line a little better. Now I want to know if the green train is still moving this way, the red train is still moving this way, and this distance is 600 miles, and 600 is given in the question. This is 600 miles. Okay, we're going to assume it takes c hours. I'm not going to write down my statement clearly because I'm just saying it, so keep that straight. We're going to assume it takes 6 hours to get to that point. Sorry, it takes c hours. So from here to here, the green train moves this way, the red train moves this way, so that the distance between the two rear ends is 600 miles. I'm going to assume it takes c hours. Now if that's the case, we can set up our equation very similar to the way we did before. In c hours, the green train will travel 55 c miles. In the same c hours, the red train will travel 65 c miles. And together the sum has to be 600. And that's 120 c. That's 600. And I divide both sides by 120, and the answer to this is 5. So it'll take the red train and green train starting here exactly 5 hours to be 600 miles apart. So now we have we're going to do our final calculation here. Oops. We'll do our, well, let me not do it this way. Let's do a little rectangle. So our A, the very first one, was 3.33 hours, and then B was 0.29166 hours. It was actually 0.29166, and then I got 5 hours now. When I add them up, these three numbers, what do I get? And I am using my calculator just for the record. I'm getting 8.359. 8.359,166 hours. That's my final answer. So it'll take the trains. Now let's go back and review the whole question a little bit. Initially the front ends of the trains was, the front ends of the train were about 400 miles apart, and the green train is 2 miles long and the red train is 1.5 miles long, and they kept traveling in opposite directions, and after about 8.359,166 hours, the two trains are 600 miles apart, and to be very specific, the rear ends of the two trains are about 600 miles apart. That's your answer, 8.359,166 hours.